Hello, this is Ms. Clausing. I'm going to go through your review sheet. Feel free to skip to whatever questions you need to see. This might get broken up into two videos, but we'll get through all these. Okay, so the first one, which function is best represented by this graph? What it's really looking for you to do is to know how to find your vertical asymptotes or your horizontal asymptotes. Of course, you could just plug all of these into y1, each equation into y1, and see which one matches the graph in your calculator and graph it. However, the real way to do this, which you can definitely do that on your test, that's fine, no problem, but show you the real way to do it is what it's asking you to do is to know how to find vertical and horizontal asymptotes. So let's just start with C, which is the answer. And the reason I know this is because my vertical asymptote, remember, is wherever my denominator equals 0. So x plus 5 equal to 0. My vertical asymptote is at x equals negative 5, right? Move that 5 over. There's my vertical asymptote. And so I know, since this is 5 over here, I know that this is negative 5 on the scale, which means I have a vertical asymptote at x equals negative 5, and sure enough, this graph does show that. The other thing it shows is where my horizontal asymptote is. Remember, for horizontal asymptotes, the rule is looking at the degree of my numerator, which is the exponent on my x, which is a 1, and the degree of my denominator, which is also 1. So if the degree is the same, so if I have the same degree, remember there's 3 rules you need to know here. If I have the same degree over the same degree, the rule is that my horizontal asymptote is at y equals my leading coefficient over my leading coefficient. So a 3, can't get quite exact here, but it's a 3 over a 1, which equals 3. So I should expect to see on my graph a horizontal asymptote, which 3 is about right here. I should expect to see a horizontal asymptote about 3. Okay? So, sure enough, my graph shows that my vertical asymptote, my horizontal asymptote answer is C. Again, you can put all these into your calculator and find that that is true by graphing. But show you the real way to do it. All right, number 2. So number 2, I'm going to kind of show you how we find what our x-intercepts are and what our y-intercepts are. So let's start with our x-intercepts. Let's start with y-intercepts. My y-intercept, I am on my y-axis when x equals 0. So to find my y-intercept, I'm going to plug 0 wherever I see x in my numerator. So I have 2 times 0 equals, plus 10. And so 2 times 0, that goes away and leaves me with my y-intercept is at y equals 10. Okay? I have 1. Y equals 10 is my 1 y-intercept. My x-intercept, I know I'm on my x-axis when y equals 0. So I want to know where y equals 0. Well, y equals 0 where the numerator, this numerator, equals 0. So if I have 2x plus 10, I could set it equal to 0 because that tells me where y is 0, which tells me my x-intercept. So I'm going to minus 10. 2x equals a negative 10 divided by 2. X equals a negative 5. Okay, so I have 1 x-intercept, 1 y-intercept. B is my answer. Okay. You could look at the graph. It's a little hard to see on the graph, but you could look at the calculator, put this equation, g of x, into y1, and you would see that you have 1 x and 1 y-intercept. Okay. Number 3. So again, this is another one. You can just put this into your calculator, into y1, and look at your end behavior. However, a way to do it algebraically is to find my end behavior I know is what's happening as it approaches my horizontal asymptote. So, just got to know my rules for horizontal asymptotes. I know I'm looking at the degree of my numerator over the degree of my denominator. They're both 2's, so I have the same degree. I'm just going to write same over same. But same degree divided by same degree. Therefore, my horizontal asymptote is at where y equals my leading coefficients, which is a 4 over 2. So y equals 4 over 2, which equals 2. So I have a horizontal asymptote at 2, which means the ends of my graph approach my horizontal asymptote. The answer is C. Okay, so that's that one. Number 4. All right. Again, just testing your knowledge of horizontal and vertical asymptotes. So let's start with vertical asymptote. I know my vertical asymptote is where my denominator, x minus 4, comes from here, equals 0. So I just add 4 to both sides. That gives me x equals a positive 4 is my vertical asymptote. Now on the SOL, you'd have to click on this x equals 4, and you would drag it and drop it in that box. All right. Now my horizontal asymptote, again, I'm looking at my degree over my degree. My degree of my numerator is a 1, because I don't see a number in the exponent here, so it's a 1. Degree of my denominator, again, it's x to the first. So 1 over 1, so I have same degree divided by same degree, or as I wrote in the last problem, same over same. Okay, same degree over same degree, so my horizontal asymptote is y equals my leading coefficient divided by my leading coefficient. Well, my leading coefficient here is 5 divided by 1. So I have 5 over 1, so my horizontal asymptote is y equals 5. So I would just grab the y equals 5 here on the SOL and drag it and drop it in this box right here. Okay. Number 4. All right. Number 5. We have identify each function which belongs to the same family. So the easiest way to do this is just to graph them. And you will quickly see graph each answer choice. The graph looks something like this, these little sketches I'll draw below each graph. So this first one looks kind of like this. Okay. The second one, when I put this in my calculator, again, I'm just putting each of these into y1 and graphing in my calculator. It looks like this. And then this one looks like this again. And this one looks like this and this. Okay? So notice the only two here that kind of look similar are this one. We're trying to match them to this graph up here. And this one. Notice they both have lines on either side of the x and the opposite side of the y. They reflect over your x and y axis. Okay? So those are your answers. Now, what you're really looking at is if you know that your graphs kind of know what your graphs should look like, you would notice that really what you're finding is that you know to have a graph that goes like this and like this, where they reflect over the x and y axis, you have an x to the first here and an x to the first here. That's what causes it to look the same, whereas these other two have a denominator with an x squared and an x that's being squared. So that's really the mathematical difference, or the difference in the equations. However, you can just put these in your calculator and look at the graphs, find the graphs that match. Okay, so there's that one. Then the next one, I actually changed this one, so if you didn't get it changed on yours, go ahead and change it now. And I changed it to h of x, and we'll write it over here. H of x equals 6 minus a divided by 36a cubed divided by a minus 6 divided by 10a to the 10th. Okay, so to solve this, first we're dividing, because we have this division sign here. So let's change it to a multiplication problem first and see what we can see. So my numerator won't change. 6 minus a over 36a, over 36a cubed. And change to multiplication, remember I just need to flip or multiply by the reciprocal of my denominator. So I'm going to flip it, put 10a to the 10th in the numerator, and a minus 6 in my denominator. Okay? So now I've changed it to a multiplication problem. But before I multiply just my numerators by my numerators, my denominators by my denominators, I'm going to see what I can cancel out. And I notice here I have a 6 minus a in the numerator on the left side and an a minus 6. They're very similar, but they're not exactly the same. So let's see how we can make them look the same. So, this in red. First, I want to make this first a 6 minus a. I'm going to put it in standard form, which is me a negative a plus 6. Signs in front of the terms stick with the terms. Now that's looking a little more similar, but the denominator has an a minus 6. Well, when I have a negative out front, what I can do is I can factor out that negative, and it leaves me with an a minus 6, like I'm taking out a GCF. Okay, so I'm just rewriting this as I go up. Okay. Alright, so now I have two factors that are the same. I have an a minus 6 and an a minus 6. I know when I'm multiplying that those will cancel out with each other. So that will leave me with a negative 1 in the numerator on the left. And let's see, does anything else cancel? Now, if you don't see something immediately that cancels, that's fine. Multiply straight across and then cancel out later. However, I notice that I have an a cubed in the denominator and an a to the 10th in the numerator. I know that this a to the 10th, this a cubed will take away 3 of the a to the 10th in the numerator. So, a cubed will cancel out this 10 and make it a 7. Okay? And that's pretty much it. So let's see. We'll end up with a negative here from this right here. We still have this negative left over. So we have a negative times my 10, a to the 7th. I'm just multiplying my whatever's left over in my numerator. All over 36 is all that's left over in my denominator. Alright, so I can simplify this. Both 10 and 36 are divisible by 2. So I'm going to go ahead and do that. So this negative 10 will become a negative 5a to the 7th divided by 36 divided by 2 gives me an 18. Okay. What I did was I really pulled a 2 out from both, right? I factored out a 2, but once I do that, they cancel, so I really didn't need to write them down. But just show you what happened there, and that gives me a negative 5a to the 7th over 18. So that's my answer here. All right. Next one. I also changed up this question a bit and changed it to be, let's see, change it to be h of x equals 4x plus 13 divided by x minus 8. And I also got rid of asking about holes, and I asked about our x-intercept and our y-intercept. Okay, so make sure you updated your worksheet to show that, but that's what we got. Okay, so let's get started. So first thing I'm going to do generally is find my vertical asymptote, because once I find my vertical asymptote, that will help me with my domain. Or you can go the other way, it doesn't matter, but that's how I like to start, so that's how we're going to start. So, to find my vertical asymptote, remember I want to take where my denominator equals 0. So, x minus 8, I want to find where it equals 0. So I add 8 to both sides. X equals 8. That's my vertical asymptote. So I'll go ahead and put that on that line. Now, where I have a vertical asymptote, actually I'll go ahead and put that on my graph as well. So I have a vertical asymptote at, oops. at x equals 8. And we always use dashed lines for our vertical asymptotes, okay? Where I have a vertical asymptote, remember that is where my domain is undefined, which means when I write my domain, I write it as all real numbers such that x does not equal where I have an asymptote, which is 8. Okay, and the squiggly brackets say it's a set of, so set of all real numbers such that x does not equal 8. All right, so I answered 2 questions there already. So horizontal asymptote. Remember, horizontal asymptote, we're looking at the degree of our numerator divided by the degree of my denominator. My horizontal asymptote, it's the same degree over same. And so my rule is that my horizontal asymptote is y equals my leading coefficient divided by my leading coefficient, which is 4 divided by 1. So y equals 4. So I'll go ahead and write that right here. And I'll go ahead and draw it on my graph. Okay, so about there. Alright, x-intercept and y-intercept. Alright, so we'll do these in blue. So x-intercept, remember my x-intercept is where my y equals 0, which means I can take my numerator, 4x plus 13, set it equal to 0, because I want to know where y equals 0. So now I'm just going to solve for x. Minus 13 on both sides gives me 4x equals negative 13 divided by 4. X equals negative 13 over 4. So my x-intercept is at x equals negative 13 over 4. Okay, and I know that's about a little past 3, so I should expect it to cross my x-axis somewhere in here. I'll just put a little dot there just so it kind of gives me a reference point when I'm graphing this and sketching my graph. Alright, last one, y-intercept. I know I'm on my y-axis or my y-intercept when my x is 0. So I'm going to plug into my numerator where x is 0, or 0 for x. So I have 4 times 0 plus 13. And I just solve. So 4 times 0, that goes away. So my y-intercept is y equals 13. Okay. Which is actually off this graph, but we'll just kind of y equals 13. It should intersect somewhere up there. Alright, so then to actually draw this graph, I'm going to go ahead and go to my calculator. Go to y equals. And remember to get the fraction, I'm going to do alpha y equals. Maybe this calculator may not work. Alright, so this one won't work. So we'll just put this in parentheses. So we have 4x plus 13. Oops. 4x plus 13 divide by x minus 8. Oh, forgot my parentheses. Alright, graph it. Oh, we're going to change our window. So my window only goes up to 10 at the moment, so let's make it go up to y max. We know there's a y-intercept at 13, so let's just make it go up to like 25, and let's see what that looks like. And I don't see it. Where's the other part? 4x plus 13 for x minus 8. Alright, we'll draw the bottom half. But we'd expect to see something come up here, like such, and go through that intersection, and then something, oh, and I put this in the wrong spot, because it's a negative 13 over 4, so it should be a little bit past negative 3, so it should come through like this, the other part of that line. Okay, so that's what I would sketch on my graph. Alright, so, not sure why the calculator wasn't working, but that's what you would expect to see, and that's how you find it by hand. Of course, you can look at your calculator, but I'd expect to see most of these points on your graph. Okay, number 8, we are going to skip. If you're in my class, number 10, you're going to skip. So let's go down to number 9. Find the quotient. Quotient just means the fraction, or sorry, the quotient just means when you're dividing two numbers from each other. So finding the quotient in simplest form. That just means divide this, solve it, okay? So all wording makes you up, just solve it. So first, when I'm dividing, I know I need to first change it to multiplication. To do that, I'm going to multiply by my reciprocal or flip the second fraction. Okay, so the first fraction won't change. It'll be x squared minus 16 over x squared minus 3x minus, I know I'm going to need more space. We'll come down here. Okay, so I'm going to write this down at the bottom. So I still have my x squared minus 16 divided by x squared minus 3x minus 4 divided by, oh, sorry, changing it to multiplication. And then I flip the second fraction, so I have x squared minus 1 over x plus 4. All right, next I need to do is I need to factor out, or factor anything I can factor. So anywhere I see a quadratic, remember quadratic is where I see an x squared. So all those terms with x squareds, I'm going to factor them before I even get started. So x squared minus 16, I know that's a difference of squares, so I can factor that pretty quickly to x plus 4 and x minus 4. Okay, over here again I have another difference of squares at x squared minus 1, so it's going to give me an x plus 1 and an x minus 1. Square root of 1 gave me my 2 1s. X squared gave me my 2 x's. Difference of squares is always 1 plus and 1 minus in my factors. This is a 4. Okay, down here we need to think of two numbers that multiply together to give me a negative 4 and add up to a negative 3. So that would be, let's see, a negative 4 would be an negative 4 and a positive 1. Multiply together your negative 4 and positive 1 gives you your negative 4. Added together gives you your negative 3. If you want to see it written out, I'm looking for two things that multiply together give me a negative 4, add up to a negative 3. So that'd be a negative 4 and a positive 1, add up to a negative 3, multiply together to give me a negative 4. So that's where those two factors came from. And then this last denominator, I can't factor it. I mean, it's already, it's not a quadratic, there's nothing I can do to it, so I'm just going to leave it. Alright, so everything's factored. So now I'm just going to cancel out anything that matches in my numerator and denominator. So I have an x minus 4 here and an x minus 4 here, so those will cancel. I have an x plus 1 and an x plus 1, those will cancel. Have an x plus 4 and an x plus 4, those will cancel. And that's it. So in my denominator, nothing is left. Everything's been canceled out. The numerator, I'm left with an x minus 1 right here. So my answer is just x minus 1. Nothing was left over in my denominator. So answer is J. All right, so let's go on to 11, which is equivalent. All it means is simplify this or solve it out. Now, we all know that when we have x cubed over x squared, that this simplifies to x to the first power, because I do 3 minus 2, which gives me that 1. Well, if I have the exact same thing in parentheses, I can use the same logic. So I have a plus b cubed, and it's being divided by a plus b squared. Well, those will cancel out with each other, and 2 of those will take away and leave me with just a plus b to the first. Okay. And then I also know that 2 divided by 18 is the same thing as writing 1 over 9, so I can simplify that as well. Alright, so in my numerator, nothing else really cancels with anything, so I'm left with an a plus b to the first power, which I don't really need to write that 1, but you can. And then in the denominator, the only thing left over is that 9. So my answer is a plus b over 9. Alright. Now, if you hadn't seen those before you multiplied it out, let me show you what you would have gotten and how you would have gotten to the same answer. Okay, so if you hadn't seen all those things I canceled and you look at this and go, nothing cancels, well, that's fine, but let's just talk about it for a sec. So I would have then just multiplied, if I looked at this and said nothing cancels, I would have just multiplied my numerator by my numerator and denominator by my denominator. My numerator would have given me 2 times a plus b cubed, and my denominator would have given me 18 times a plus b squared. Alright, so 2 divided by 18 gives me 1 over 9, so that would have left me with a 9 in my denominator. Well, 1 over 9, but I don't ever need to write that 1 when I'm multiplying. So leaves me with just a 9. And a plus b cubed, when I have the exact same thing, and I'm dividing them, I subtract their exponents. So 3 minus 2 would have left me with an a plus b to the first in my numerator, which is the same thing as f. Okay, so 2 ways to look at it. Either you don't cancel anything out and you multiply straight across and you still will get to the same answer in the end. Alright, 12. Let's see. If defined, which is an equivalent form of this expression. Let's skip this one too, actually. If you want to do it, the answer is A. Actually, we'll go ahead and do it. Never mind. Go ahead and do it. Alright, so again, we're going to do before we multiply, because we're multiplying here in the middle, right? So we can look and see if anything cancels with each other. And I'm looking for the same thing in the numerator as I see in the denominator. Well, I see this 3 here and a 3 here, so I'm going to go ahead and cancel those out. 3 divided by 3 is 1, so I don't need to write that down. I also see I have a 5 and a 10. Well, I know 5 divided by 10 is the same thing as 1/2, so that will leave me with a 1 over a 2 here when they simplify. I don't really need to write that 1, but I'll just write it there so you can see it, see where it's coming from. And then if I see nothing else that cancels at this point, I'm going to go ahead and multiply what's left over, and then I'll see if something else cancels. Or I might see, wait, there's stuff that still cancels, which there is. So I see I have a z and a z. So z to the 4th and z to the 1st. When I have 2 variables, I subtract their exponents. So this 1 basically steals, this one z to the 1st basically steals one of the z's in the numerator and leaves me with a z cubed. Okay. And then let's look at this y. This y in the numerator, y to the 1st, basically steals one of these y to the 4th. So that leaves me with a y to the 3rd. So that leaves me with a y to the 3rd there. And there's no x to cancel out the x in the bottom, so I'll just leave that. So what I'm left with is 1 times z cubed, because remember this was a z cubed, not just a 3. 1 times z cubed in the numerator, so basically just a z cubed, over a 2 times the x times the y cubed. Okay? So that's that one. Let's see what else. We have 13. Okay, I think I'm going to pause here and I will split the rest of this into a second video. Okay, so that's it for part 1. We'll do part 2 with the variation also in the next video.